morning, Satyam Puri here. So today we are going to discuss top 5 physics problems from the chapter Conservation of Momentum. If you're a student of class 11th or equivalent grade, these class 11 physics numericals will be helpful for you. If you're a student of IIT JEE or preparing for IIT JEE or some competitive exams, so these questions are of advanced levels. Definitely this question will be interesting and will be useful for you as well. So let's start now. Let's start with the question number 1. So question number 1 says a block of mass 1 kg is moving towards a movable wedge of mass 2 kg as shown in the figure. All the surfaces are smooth. When the block leaves the wedge from the top, its velocity is making 30 degrees with the horizontal. So we have to find the value of V naught here. We have to find the value of V naught. You have to find the velocity of that's 1 kg mass. Okay. So that's the question. You can pause this video. You can try to think how to solve this. So before going ahead with the solution, let me explain the question so that you get 2 times to think and 2 times to analyze the question, and then you will see the solution. That will be helpful. Okay. So the question says there is one mass 1 kg and there is a wedge 2 kg. Okay, this mass is given some velocity and they are placed on a horizontal smooth surface. I don't think there is a friction. Okay, there is a smooth surface. So this small mass 1 kg is given some velocity v naught, and that we have to find out. This is given some velocity v naught in such a way so that when it slides on the inclined plane and when it leaves the inclined plane, it has angle 30 degrees with the horizontal. So that is a given condition. So we have to find that velocity. Okay. And the angle of inclination of this wedge is also given 60 degrees, and the height of the wedge is given 1.45. So to solve this question, let me draw the figure first. So let's draw the first figure first. So this is the initial condition. Let's draw a horizontal line, and there is a mass 1 kg and it is giving velocity v naught. Obviously this mass 2 kg has at this time the velocity is 0. So a final time what will happen, this mass, the wedge starts moving due to the normal reaction of this 1 kg block, and when this 1 kg blocks reaches here, it will have some velocity v, and angle it must be, let's say, theta with the horizontal, and that theta value is given 30 degrees. So better we'll write this theta angle only. So this velocity is making 30 degree angle with the horizontal. Okay. So to solve this question, and we have to find we just have to find the v naught, but there will be some velocity in the x direction of the wedge also at that time when it is leaving the wedge. So what we can do here, we can apply the momentum conservation. Let's say this is the initial condition and this is the final condition. So we can apply the momentum conservation. So write momentum conservation equation. Momentum conservation equation. So the initial moment, obviously it is just one mass 1 kg and moving with v naught velocity. So 1 into v naught equals to final momentum we have to write. So 2 kg wedge is moving in this direction, Vx. So 2 Vx we can write plus. Now this 1 kg mass is moving in this direction V. So it have 2 components. One is V cos 30 and V sin 30. We are writing momentum conservation in horizontal direction only. So we need to write the velocities component in the horizontal direction for the 1 kg mass. But this V we have assumed with respect to the wedge, So since it says it is making 30 degree with the horizontal, that means with the horizontal that mass is making 30 degree with with respect to ground. So let's write this v. We assume this v velocity with respect to wedge. So what we'll write is, we'll write v cos 30 plus vx. That is the speed of the 1 kg mass from the ground frame. So this is our first equation. Next equation we'll write is energy conservation. So we'll write energy conservation. So energy conservation, since there is no loss in energy in terms of friction, so we can say that initial kinetic energy plus potential energy equals to final kinetic energy and potential energy. So what is the initial kinetic energy? We can write as half into 1 into v naught square equals to, what is the final kinetic energy? So obviously half into 2 kg into vx square. That is the final kinetic energy of this wedge, plus half into 1 kg into this velocity that we have written, v cos 30 plus vx square, and plus we need to write one more thing. There is a potential energy gain and this height is given 1.45, so we'll write 1 into 10 g into 1.45. Okay, so this is our second equation. So now the third equation, since how many variables we have? We have variable v, we have vx, we have two variables, and we need to find the wedge velocity vx. So do we have any other variable? We don't have. I think we can able to solve these two equations. Okay, so now let's write the third equation. We need the third equation. So third equation will be, we have this velocity v and we have the two components of this velocity, because this is 60-degree angle, the inclined plane. So this component is v by 2 and this component is root 3 by 2v. But from the, this is with respect to inclined plane. This is with respect to inclined plane. These are the velocities. Now with respect to ground, if I draw the figure will be, this angle makes 30-degree angle and this length will be root 3 by 2v, and this will be v by 2 plus vx, right? The horizontal velocity with respect to ground will be the velocity with respect to the wedge plus velocity with respect to the which it is moving, with respect to wedge plus velocity of wedge with respect to ground. So now we have the condition, the tan theta, which is tan 30, is 1 by root 3 equals to root 3 by 2v divided by v by 2 plus vx. If you solve this equation, you will get vx equals to v. So we have the third equation, vx equals to v. So now vx equals to v. Now from, if we substitute in the first and second equation, we can get the v naught. So let's substitute in the first equation. So first equation is v naught, so we'll write v naught equals to 2vx, we'll write just 2vx only, plus v cos 30, so v cos 30 will write vx root 3 by 2 plus vx. Okay, so now what we are getting is, we got this as vx common, so 3vx, 3 plus root 3 by 2. So we got as 3 plus this. So we have 3 plus root 3 by 2, 3 plus root 3 by 2
into Vx equals to V0. This is our first dash equation. Now the second equation, if we substitute V0 square by 2, we'll write V0 square by 2 plus, if we substitute Vx and V, so Vx square, we'll write in terms of Vx only, equals to Vx square plus, in the second equation we miss this thing, we have to add the vertical component of the kinetic energy also, so half 1 into V by 2 whole square, half into 1 into V by 2 whole square, that is the vertical component, and the horizontal component is root 3 by 2V plus Vx, and that is whole square, that is the kinetic energy of this, plus gravity, so 1 into G into 1.45. okay, so how many variables? Let's just replace V with Vx, so Vx, so what we got here is, we got V0 square by 2 equals to Vx square plus 1 by 2 into Vx square by 2, so Vx square by 4, 1 by 4 plus Vx we can take common, so 1 root 3 by 2 plus 1 whole square, and further Vx square plus 14.5. Now Vx we can replace with V0 by, this Vx we can replace with V0 by 3 plus root 3 by 2. Okay, so this is the Vx. Now if you replace this Vx in this equation, we can get the V0, because in this equation we have two variables Vx and V0. So if you replace this, so I'm not solving this is taking time, so this V0 will come 7 meter per second, so that should be your answer. You must calculate and check that. Okay, so that's the question number 1. Now let's quickly go to the question number 2. The question number 2 is, a bead can slide on a smooth straight wire and the particle of mass small m. A bead can slide on a smooth straight wire and a particle of mass m is attached to the bead by a light string of length L. The particle is then in the contact with the wire with a string taut and is then to fall. If the bead has a mass 2m and the string makes an angle theta with the wire, then bead would have slipped at a distance. So this question we have to understand first. So let's say we have a bead which is attached to a string, and this bead, there's another block or the mass is attached, which mass is m, half of this mass, and this is released like this. The distance between them is L right now. Now it is released. So as it is released, this bead is free to move. So as it will go down with the help of gravity, this is constant to move in this direction only. So this will go in this direction, this will come like this. So the motion will be something like this. But since the entire system, there is no horizontal force acting on the system, so we can say that there won't be any movement in the horizontal direction of the center of mass. So what we can say that, so we have to find when this string makes an angle theta with the wire. So this is the angle theta. So how much the bead would have slipped a distance. So this, how much will move, so that distance we have to calculate. So we'll draw the figure first. So this is the bead and this is the mass here. If you leave this mass, then let's assume this moved by a distance x and this came here. So with respect to this, how much distance this will move? This is L and this is theta, so this must be L cos theta. So this will be L cos theta. That means this particle have moved a distance L cos theta with respect to the wire. This is L cos theta with respect to wire, and this x we assume, let x is the distance moved by bead with respect to ground. So we have assumed the x distance with respect to ground, but we assume L cos theta, which will be L cos theta. The distance, the moment of this small mass m. So this is having 2m and this is having m. So this moved L cos theta. So now, if we write the since the center of mass in the horizontal axis will not move, so what we can write is m1 x1 plus m2, or we can say the change in position of the center of mass. What we'll write is, we'll write m into delta x1 plus m into delta x2 as to be 0. m1 into delta x1, m2 into delta x2 will be 0. m1 is mass 2m, and what is the displacement from this point? It is x plus. Now what is the mass m2? m. And what is its displacement from this point? Initially, what is the displacement? At L initial, this mass was here. So this mass initial length is L, initial distance, initial coordinate we can say it is at a distance L. But the final coordinate is L minus L cos theta. So this is the final coordinate, L minus L cos theta. So this is with respect to wire only, but this moved x distance, so we have to subtract this. So what we can write is, we'll not write this, what we'll write is x minus L cos theta. Okay, x minus L cos theta is L minus L cos theta is the distance moved by this small m. Distance moved by small m with respect to wire. So this L minus L cos theta is moved in this direction. So from this direction we can say it is moved L minus L cos theta. From the ground, how it will look? It will look, this entire moved with respect to this, it is L minus L cos theta. So from the ground, x again displaced. So x minus this distance. So x minus L minus cos theta. So it will come, and that equals to 0. So I will write 3mx equals to L into 1 minus m L 1 minus cos theta. So this implies okay, so that's the answer. So this is the answer. This is the movement from the ground. Okay. So now let's move to question number 3.
So question number 3 says a ball is projected from a ground with a speed u at an angle alpha with the horizontal. It collides with a wall at some distance from the point of projection. So this distance is given. The coefficient of restitution between the ball and the wall is E. Okay. The time taken, the path AB, and the maximum height attained by the ball we have to calculate. Okay. So basically there is a wall and there is a point here where an object is thrown at an angle alpha with u velocity. So what will happen? It will collide and come back here. So this, where it come back, that distance A is given, where it come back at the end. So we have to find the time taken from here to here, and what is the maximum height that it will go. It will go like this possible, like this possible. So there are different combinations possible. So
So let's try to solve this question. So first let me draw the figure. So let's say we have this wall. So an object is thrown at an angle u, at an angle alpha with velocity u. What will happen? This will go like this and go like this, and this distance we have given a. Okay, so it's written that all the surfaces are smooth. That means when this ball collides with the wall, so here let's say it has initial velocity in the horizontal direction u cos alpha and vertical velocity u sin alpha. Okay, so in horizontal direction, is there any force except normal of the wall? There is no other force. So horizontal velocity remains same. Okay, not remain same. We have this coefficient of distribution. So here it will collide with velocity u cos alpha. Okay. So in horizontal direction only, it will get reflected back with some certain velocity because the coefficient of distribution is given. So we have the relation E equals to V separation by V approach, and V separation we need to find, let's say Vs, and V approach we know V cos alpha. So V separation we got it E times U cos alpha. So this is the velocity at which it will reflect it back. So this velocity is EU cos alpha. Okay, so just note down this. This is the velocity at which it will be reflected back. So EU cos alpha. So finally U cos alpha and then EQ cos alpha in the horizontal direction. Let's talk about the vertical. In vertical direction there is only gravity acting and there is no friction on the wall. So vertical component will be unaffected. That means time period will be unaffected. So time period will be very simple to calculate. It only depends on the initial velocity. So 2u sin theta by g, that is the formula we have. So theta is here alpha, so 2u sin alpha by g, that is the time period here. And the maximum height will be, so we have to calculate now the maximum height. So maximum height in terms of a is given we have. So time period, we know that time period will be this. So the maximum height, okay, so let's calculate that. So EU cos alpha in this direction and U cos alpha in this direction. Okay, so vertical velocity we got it. Vertical component is not changing. Vertical component is not changing. So vertical component is not changing. So time taken path AB. Okay. So this is the time period. The entire time period from here to here. We have to calculate the time period for this path. So for this path, the time will be from here to here. Let's say we have the maximum speed, 1 second. So we got that equation that it will reflect with the velocity EU cos alpha. So now we have to calculate, we have a B point and we have this A point. We have to calculate this time. So we can calculate we know this speed is eu cos alpha, so we can write eu cos alpha into the time AB equals to A is given, so we can say that time AB equals to A divided by eu cos alpha. So this is how we calculate the time. This is very easy to calculate. Now the second question is the maximum height. Maximum height attained since the vertical component of the velocities are not affected by the wall, since the wall can apply only normal reaction and there is no friction. So this will just go up, and the normal height formula we can use. So we have the formula for height, u square sine square alpha by 2g, and that's all. That's the height and that's the time. So this is the question number 3. Okay, so let's go to the question number 4. So question number 4 is a mass m moves with a velocity v equals to root 3 meter per second and collides with another mass 2m initially at rest. After collision, the first mass moves with velocity v by root 3 meter per second in the direction perpendicular to the initial direction of the motion. The speed of the second mass after collision we have to find. So well, this question we have to understand first. So there is a mass m which is moving with root 3 meter per second and collide with another mass 2m which is at rest. Now it says that after collision, the first mass moves with v by root 3 meter per second in direction perpendicular to the initial direction. That means the collision, there are of two types. One is the head-on collision, where the mass must go in the same direction, but here the direction differs. That means the collision must be oblique. Oblique means there are some different diameters, or they must collide with a certain angle. So something like that we have to think. So let me draw the figure. Let me solve this question. So we have this mass m which is moving with velocity root 3 meter per second. Okay, and we have another mass 2m which is initial velocity is 0. We can say this is u1 and this is u2. After the collision, what happens? This m moves with in this direction with a speed v by root 3. So we have to find the speed of the second mass. So we don't know the second mass in which direction it will move. So we'll assume the second mass moves with velocity vy and vx direction respectively, okay, in horizontal and vertical direction. So this is the initial situation and this is the final situation. So we need to find, okay, so we need to conserve the momentum in the both directions. So conserving momentum in horizontal direction. So horizontally the initial momentum is m into root 3 and the final momentum in horizontal direction is 2m into vx. Okay, 2m into vx. So what we can get from here is we can get vx as root 3 by 2v. So this is our vx. Now we have to find vy also. So we can write momentum conservation, conserving momentum in, what we'll write is conserving momentum in vertical direction. So vertical direction, initial momentum 0, so final momentum also has to be 0. So the final momentum is m into v by root 3 plus 2m into vy. So from this we can get, I will write it here. So 2m vy equals to minus of mv by root 3, mv by root 3. So this mass get cancelled. So we got vy, obviously it should be negative, minus v by 2 root 3. So this is our vy. Once we get vx and vy, so the velocity, the speed of the second mass of the collision will be, v will be root of vx square plus vy square. So that means we have vx and we have vy. Vx is root 3 by 2v, so root 3 by 2v square plus Vy we get minus v by 2 root 3 square. So when you square it, we will come out, I will get root of 3 by 4 plus 1 by 12, which is 3 into 3, so 9, 10 by 12. So into 3 and into 3, so 9 plus 1, 10 by 12. Root, we did mistake, 3 by 4. 3 by 4 plus 1 by 2 to the 4, 3 are 12. So 3 by 4 plus 1 by 12. So let's multiply 3 into 3. So what you can write is 9 by 12 plus 1 by 12. So 10 by 12. So root 10 by 12v. So that is the speed. So root 5 by 6v. I think that's the answer. Tell me if I did any mistake. Speed. Root 5 by 6v. Okay, so that's the question number 4. That's the speed. So now that's the answer. So let's do the question number 5. Question number 5 says an object is projected. So question number 5 says an object is projected with a speed 10 meter per second at an angle 30 degree with the horizontal. Okay. So an object is projected 30 degree with the horizontal 10 meter per second, and the object breaks down at some path into n fragments during its motion. So the object breaks down into n fragments during its motion, and one fragment is found to strike the ground at a distance of root 3 and another found at a distance of in this object and the center of mass of the remaining fragment strikes the ground at a distance 7 root 3 meter from the point of view. Okay, so that's the question number 5, the last question. The question says an object is projected with a speed 10 meter per second at an angle 30 degree with the horizontal. The object breaks down into n equal fragments during its motion. One fragment is found to strike the ground at a distance root 3 meter from the point of projection in the same azimuthal plane in which the object is projected. If the center of mass of the remaining fragment strikes the ground at a distance of 7 root 3 meter from the point of projection, then find the value of n. So we have to find the number of fragments. So first try to understand the question. We have one horizontal line and one object is projected at angle 30 degree with some velocity 10 meter per second. Now it should go in a projectile motion because only gravity is acting. So no matter how many fragments happen because of some internal forces does not deviate the path of the center of mass. So one fragment reaches at root 3 meter per second, root 3 meter from the initial point. Another fragment or the center of mass of the remaining fragments reaches at 7 root 3 meter. So let's find first what is the range. Okay, so to solve this question, let's take an object. So the object, the path is like this. The center of mass must go in this direction, and this velocity is 10 meter per second, and this angle is 30 degree. If you calculate the range of this projectile, it will be u cos theta into time period. So 10 cos 30. So 10 cos 30 horizontal speed into total time. So total time will be 2 into u into sine 30 by 10. Okay. So what you will getting is, you will get 10 cos 30, which is 5 root 3. So 5 root 3 meter, I got the range. That means this resistance must be 5 root 3. Now as per the question says, the one fragment, let's say explode here. So one fragment reaches here, another fragment goes beyond that. So this distance they have given you, this distance they have given √3, and they have also given this distance as 7√3, the remaining fragment distance. So as per the center of mass remains same at the position of let's say when all the fragments reaches on the ground, the center of mass must be here. We know the center of mass must be here. So we can write as 5√3 equals to RCM equals to M1 R1 M2 R2 divided by M1 plus M2 basically. Okay. So 5√3 is the center of mass location after the explosion and after they reach the ground. So M1 is, let's say, mass of the one fragment is 1 unit, 1 into √3 plus the remaining mass obviously will be n minus 1 unit into 7√3 and divided by total unit is n. Total mass is n. So let's solve this equation. So 5√3n equals to √3 plus 7√3n, √3 plus 7√3n minus 7√3. Solve this equation, so we'll get 2√3n equals to 2√3n equals to 6√3. So that equals n equals to 3. Number of fragments is 3. So there will be 3 fragments. Okay.
So this question also based on the center of mass, or basically the conservation of momentum chapter. So conservation of momentum, having these 5 questions which are very useful actually. So for those who are preparing for IIT as well as for the class level students, it's very good numerical questions, physics numerical questions. So fine, so that's all for today. If you have any question, go ahead and write in the comment box. I will try my best to reply. So see you guys next week.